Okay, so the first question is just a polynomial, and it tells you it has a root of multiplicity 2. Ultimately, that just means there's going to be 3 different solutions here. 2 of the solutions are going to be the same, right? So one of these roots is going to multiplicity of 2 is doubled up. But to be fair, this polynomial is just of degree 3. So I actually would just be solving this like normal. To be honest, it's probably going to be just as quick. I don't know, maybe using the root of multiplicity 2 maybe may result in a slightly quicker solution, but not much. I'll show you both methods, to be honest. All right, so just firstly, if you were to solve this polynomial equation, you have to try and guess and check your first solution. So I'm going to look at plus or minus 1. Typically, I'm looking at factors of the last term. Sometimes the last term over the very first coefficient. But anyway, I'm going to sub in 1, see if that works. 4 minus 8. Yeah, that actually works. Okay, so let x equal 1. And if you do that, very nicely, you end up discovering that is actually equal to 0. Therefore, x is equal to 1 is like a solution or, a root, if we're to use the same terminology of the question, which implies if x is equal to 1 is a root, then x minus 1 is a factor. Remember, right, when we're solving polynomials, we want to factorize the expression, and then each factor you just let equal 0. Okay, so x minus 1 is a factor, so we have our first factor. Typically, what we do at this point is we then do our synthetic division. We've got this number here. Don't know what it is. And we're going to divide it by a factor. All right, so just go ahead, do this as per normal. Where do we go? Take these away. Okay, move on to the next one. What do you multiply x by to get minus 4x squared to minus 4x? New term goes at the top. Minus 4x times x is a minus 4x squared. Minus 4x times a minus 1 gives you a positive 4x. Take these away, they cancel. You're left with just an x here. Drop the minus 1. What do you multiply x by to get x? Well, it's just a positive 1, and so new term at the top. 1 times x is x. 1 times minus 1 is a minus 1. When you take these away, they cancel. You're left with a remainder of 0, which is what we needed because we were dividing by x minus 1, which is a factor, right? When you divide a number by a factor, you shouldn't get a remainder. So what we've now established is that the polynomial, we've now partially factorized it. To look like this, right? We're trying to solve it. So, the next step, I'm going to have to add an extra page in here, is let's complete the factorization. So we have x minus 1, 4x squared, was it minus 4x? Plus 1 is all equal to 0. Ultimately, you just factorize in this trinomial. Whichever way you choose to factorize, go for it. It's actually perfect square. Okay, so you fully factorize that trinomial there, and we've now got, here, I won't even put the squared there. I'll write it out as separate factors. Okay, we've fully factorized the polynomial, and from here, you can then work out your solutions. Therefore, x would be equal to 1, which is the first solution we got through guessing and checking, right? And the other 2 solutions would be a positive 1/2 and a positive a half. They're the three roots of that equation, or in other words, solutions. There's only two unique solutions because one of them ended up being doubled up, which we kind of knew would happen because the original question told us that that has a root of multiplicity 2. One of the solutions will be doubled up. All right, so that's how I personally would go ahead and solve the equation. I would just solve it like normal. However, how could we have used the fact that it said multiplicity of 2 to help speed up the process? Well, if you've been told that that has a root of multiplicity 2, right, then that means typically what you'll do is, hey, you would let the roots be, well, normally it would be alpha, beta, and gamma, right? Or delta. I don't remember my Greek letters anymore. Right, but in this case, we know that two of them will be the same. So technically, the roots would be like alpha and beta. Two of them will be the same. And from there, what would that allow you to do? Well, ultimately, remember your sum and product of roots. Remember, you add the three roots together, and that gives you minus b on a, remember? Implying 2 alpha plus beta is equal to, in this case, what was the original one? Minus b on a, that's just going to give you a positive 2. It gives you an equation. I go on to your next one. Right, the next one down is when you combine them in products of 2. So you're going to end up with an alpha squared plus an alpha beta plus another alpha beta. And that would be equal to c on a, which of course would imply that alpha squared plus 2 alpha beta is equal to c on a. So this would be a 5 on 4. And the last one is where you multiply all of them together. So it'd be alpha times beta. That's equal to minus d on a, which implies, alpha squared beta is equal to minus d on a will end up being a positive 1 over 4. What this does is it gives you 3 different equations with only 2 unknowns. You could actually combine 2 of these and solve them simultaneously to get your solutions. Ultimately, you end up getting these solutions here. But that's how you could use the fact that it had multiplicity of 2 to maybe slightly shortcut it. You're still stuck with an annoying simultaneous equation to solve, but it does work that way. So that's the 2 different ways you could go ahead and solve the first question that was put forward. Now, the next one is another polynomial. It's of degree 4 now. It's going to have 4 solutions, and we're told it has a root of multiplicity 3. Just because of the extra, the fact that there's 4 different solutions, I would not use the normal way, the first way I did here. I love using this method here when it's of degree 3 because it's pretty simple. You guess and check one solution. You get to do your division, which I find really fun, and then you're just left solving a quadratic, right? So it's a pretty easy method. When it's of degree 4 though, once you've guessed and checked and you divided, then you end up with a polynomial of degree 3 and you gotta repeat the whole process. It becomes longer. I actually would be using the second method for here. I would use this information they've given us to shortcut the working out for this question because it actually will make a big difference. If you have a root of multiplicity 3, that means there's 4 solutions here. 3 of them are going to be the same. So our roots won't be alpha, beta, gamma, lambda. 3 of them are all the same. So technically, this one here has roots of alpha, 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 and beta. There's still yet 4 roots. 3 of them are the same. So this is going to simplify. So when we use our sum and product results and solve our equations simultaneously, it's going to simplify quite nicely. Let's check it out. So the first one, you add them all together and it equals minus b on a. So in other words, I'm just going to shortcut the simplifying here. 3 alpha plus beta will equal to minus b on a. All right, so you get your first one there. The next one along, notice the x squared is missing, right? The coefficient of x squared is 0. So combining these in pairs of 2, alpha squared, alpha squared, alpha squared, we end up with 3 lots of alpha squared. Plus 3 lots of alpha beta, and that would be equal to what would be c on a, in other words, 0. Okay, so that's the second one. I'm already thinking that might be all I need to start getting solutions. But anyway, let's write them all out. Combining them in groups of 3 now. Okay, we've got an alpha cubed, alpha squared b, alpha squared b. Okay, so you've got an alpha cubed plus 3 lots of alpha squared beta. If you're not sure what's happening here, look back over the sum and products of roots. And so we're up to, we had minus b on a for the first one, c on a, we're up to minus d. So this ends up being a 16. And the final one is where they're all multiplied together. And that would be a minus d. Wait, so minus b plus c minus d. Oh, we're up to an e. Okay. All right, so we've got our 4 different results using the sum and product formulas. And from here, ultimately, we're just solving simultaneously to get our solutions. With that being said, though, I think like this one here. So notice there's only 2 unknowns, alpha and beta. And there's 4 different equations. So we actually have a surplus amount of equations. We'll see. But anyway, looking at this first one here, simplifying this, check it out. You got 3 alpha outside of alpha plus beta is equal to 0. This implies that alpha is equal to 0, or the second one, alpha will be equal to minus beta. Now, we know alpha can't be equal to 0, because if that was the case, 3 of the roots is 0, which isn't a solution at all. So we're left with, this is the solution. Alpha is equal to minus beta. So if we sub this result here into the top one, I think we can get our first solution pretty nicely. I would be tempted, actually, that doesn't matter. Let alpha equal minus beta. So here you're going to end up with, so subbing this into the top, or I should say the first equation, you're going to get minus 3 beta plus beta is equal to minus 4. In other words, minus 2 beta is equal to minus 4. Beta is 2. We've found the value of that root right there. That's a 2. All right, so what's alpha going to be? Well, therefore, alpha is equal to minus beta, right? That is this result right here. So obviously, alpha will be a minus 2. So, therefore, the roots or solutions or zeros, right? All 3 words get used to roughly mean the same thing. Will be, we've got a minus 2, minus 2, minus 2, and a positive 2. They're the zeros of our equation. Much easier than having to go through the normal methods of guessing and checking one of them. dividing. Like that method will work, it'll just take a lot longer. So this method here of using the fact that they gave us, hey, one of the roots has multiplicity of 3, having 3 of those being the same was too much of a temptation not to use. You know, yes, you're stuck having to write these out. As it turned out, we actually only needed the first 2 to make it work. If you've got 2 unknowns, typically with simultaneous equations, you only need 2 formulas, as long as they're unique formulas, you know, to solve it. So, yeah, pretty cool question. All right. Oh, and if you wanted to know what that thing would be factorized, once you've got the zeros, you could always backtrack, right? You don't need to. But if the thing did ask you to factorize that expression, you know, if you got a 0 of -2, x plus 2 would be the factor. There's actually 3 of them. And the 0 of +1. Oh, sorry, that was a +2. That would be a -2. So that there would have been the expression if it was fully factorized. All right, the next question that was put forward. Okay, yeah, I actually already did the I did all these questions before I'm doing them now, to be honest. The question that was given yesterday, you know, it was easy enough. You could just knock it off on the spot. But I actually did solve these beforehand just because there's so much that can go wrong. So this one here, okay, we were given the sum of its roots is 0, or of 2 of its roots. So what that means is it's of degree 4, so you normally have 4 roots or 4 zeros. The sum of them, of 2 of them, is 0. So that means, check it out right here. If 2 of them add up to give 0, that means 2 of them must be the opposite of each other. That's what that piece of information tells us. Now again, because it's of degree 4, I would be really reluctant to go through the normal method of solving this equation, you know, using, you know, guess and check in, synthetic division. You then have to guess and check again on that, divide again. You know, it'll take too long. It's too big a process. I'm going to use the piece of information they gave us. And what's kind of cool is when you write out, again, your sum and product of the roots, right? This is the minus b on a one at the top. This would be the c on a, the minus d on a, and the positive e on a, right, to get your 4 equations. What's kind of cool is because of the alpha and the minus alpha, there's lots of times where terms cancel. Like if you just look at the first one, the product, where you add the 4 terms together, alpha plus minus alpha plus beta plus gamma, all you end up with is just the beta plus gamma, right? The alphas cancel. And so the equations end up simplifying quite nicely. And again, you're stuck with this situation. Now, there are 3 unknowns to find. We need to find alpha, beta, and gamma. But again, I still think this is going to be quicker than the normal traditional way of not using the clue they gave us. All right, so solving these simultaneously. And I'm trying to remember what I did. I think we can just, you know, just work it out anyway. I don't think it will be too bad. Equation 1 is so nice. I see it combining with equation 3 pretty nicely too. I'm thinking about factorizing out a minus alpha squared here. Because if we do that, we end up with beta plus delta. Which is, okay. All right, yeah, I think this is going to be my path. All right, so here it is, bam, bam. I've factorized the minus alpha squared on the third equation out, and I'm then going to sub the first equation in because I know what beta plus alpha beta, yeah, gamma. I keep calling it, I'm going to call that thing gamma. I know what beta plus gamma is equal to, so we end up with a minus, ultimately a quarter, alpha squared is equal to minus 3 on 4. Okay, we end up with alpha squared is equal to 3. Therefore, alpha is going to be equal to plus or minus root 3. Hey, and you're saying we've got two different solutions here for alpha. Well, we expected that, right? Because check it out. Go back to our zeros here. We know for that first one that was almost doubled up, one was going to be the opposite sign of the other. We have the first two roots. One of them is a positive root 3. The other one is a negative root 3. All we're left to do now is just find the final two roots. That's going to be a whole lot easier now that we know what alpha is. So now that we know what alpha is, go look at one that has, alpha, beta, and gamma in it. That doesn't look too bad. Probably the bottom one. All right, so we've got this. So now I'm going to look at the bottom formula. I'm using this to try and, work out what beta and gamma are going to be. I'm probably going to combine the bottom one with the top one. Is so nice. It's going to help us. All right, so firstly, looking at equation 4, we know alpha squared is equal to 3, right? So I'm going to replace this alpha squared with 3. With minus 3, beta gamma is equal to 9 over 8. In other words, beta gamma is going to be a negative 3 on 8. So this here is an equation with two unknowns. And if we pair it up with the first one, beta plus gamma is equal to 1 on 4. Here we can see, right, we just have two equations, two unknowns. We're going to solve this simultaneously to find the final two zeros. So that's exactly what we end up doing. Here I'll rearrange. Let me get back to orange. So delta is going to be a negative 3 over 8 beta. I'm going to sub this into the second one. So beta plus, so delta is a negative 3 on 8 beta, which is equal to 1 on 4. I'm going to times everything by 8 beta. This term over here on the right, you times it by 8 beta, right? And then you bring it across. I've done it like this because, I'm trying to get it look like a normal quadratic equation. Okay, so let's zoom across to the next page. Let's just firstly make sure I didn't make any mistakes. Alpha squared was definitely 3, so I subbed that into this here. Yeah, everything looks pretty cool there. So that should be a negative 3 on 8. Okay, all right. Okay, so I think we're going good. All right, so let's go ahead and solve this equation. So we had 8 beta squared minus 2 beta minus 3 is equal to 0. And just go ahead and solve that quadratic. I'm going to hope it factorizes just because that's way more fun. How can we get a negative 2 here? Okay, I'm using a different method here, right? I'm using cross method because that's the method I always used to use. But it doesn't matter. All the normal methods for factorizing all work. They're all fantastic. And you end up with two different potential solutions for beta. So beta could be equal to 3 on 4, or it could be equal to negative 1/2. I'll tell you this, these are our solutions for beta and gamma. So if beta is 3 on 4, when you sub that back into the first equation, the one that we have here, it'll tell you that gamma is equal to minus 1/2. Alternatively, if you subbed beta, if you let beta equal the minus 1/2 into that equation, it'll tell you that gamma is equal to 3 on quarters, right? It doesn't matter when we originally, whether it's beta or gamma, it doesn't matter. These are the values of our final two zeros, or roots, solutions, x-intercepts, whatever you want to call it. So therefore, we have our roots. So the roots are going to be, it was a root 3, a minus root 3, a negative a half, and a 3/4. They were the solutions to that equation there. Again, using the shortcut of the sum of two of its roots is 0. It just gives you that clue. It tells you that two of the roots are the same but opposite signs. When you write out your sum and products, a lot of those equations simplify down. And so when you do your simultaneous equations, it's a little bit nicer because you've got 3 unknowns there instead of 4. All right, we're going to leave it there. Hopefully this helped. Best of luck, and I'll see you guys again next time.